Happy Friday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@yvcc.edu and I'll respond as soon as I can. I know you were excited to hear that message this morning because you've never heard it before. All right, so eventually today we're going to go on and take a look at section 9.4. But first, I got a request for several problems from a student from section 9.3. And I went through and looked at what the student had done in WebAssign. And actually, most of their questions, the answer they had was correct insofar as they had gone with it, but they had one step further they needed to go. And I'm going to talk about that. First of all, let's take a look at, this is number 9. It says, simplify the radical expression. All variables represent positive real numbers. So the fact that it says all variables represent positive real numbers means we don't have to worry about absolute value bars as part of our answer. Okay, so we've got the square root of 448, a cubed, b to the 5th. So first of all, let's take a look at 448. 448, 2 goes in 224 times. 2 goes into 224 112 times. 2 goes into 112 56 times. Let's see, 2 goes into 56 28 times. 2 goes into 28 14 times. And let's keep going here. 2 goes into 14 one time with a 7 left. Let's see, 2, 4, 8, 16, 32, 64. Let's see, is 64 times 7? Yes. Okay. So I've got 2 to the 6th power times 7. So I'm going to go back over here and rewrite this as 2 to the 6th power times 7 times a squared times a times b to the 4th times b. And what I'm doing is, we talked about yesterday how you want the exponent on the base inside to either match the index or be a multiple of the index, okay? So 6, 2, 4, those are all multiples of the index. So now, the square root of 2 to the 6th would be 2 to the 3rd power outside. The square root of 7 stays inside. The square root of a squared would be a outside. The square root of a stays inside. The square root of b to the 4th is b squared outside. And the square root of b stays inside. So then I've got what? 7ab inside. So finally I've got 8ab squared times the square root of 7ab. Okay, so that's the correct answer. Now what I want to do is I want to show what the student that asked about this had. Okay. Their answer is this. They've got 8 times the square root of 7 times ab squared times the square root of a times the square root of b. Now, all the information that is there is correct, but what needs to be done is things need to be condensed more. If you'll notice, I took these and put them all together, okay, 8ab squared, and then I took those and put those all together, 7ab under a radical. So it wasn't so much that they did it wrong, they just didn't go that next step to put things together, okay? Now, they did the same thing on some other problems, and I want to just go through. I'm not going to do the problems, I'm just going to show, let's see, this is number 12. It said the 7th root of 256 t to the 6th power. The correct answer is -2 7th roots of 2t to the 6th. What the student has was -2 times the 7th root of 2 times the 7th root of t to the 6th. Again, all the pieces are there. They just needed to put things together, okay? So to the student who asked these, you were on the right track, you just needed to go a little further. Let's see, let's take a look at 29. The problem is the square root of 200 x squared y. The correct answer is 10x square roots of 2y. You had 10 times the square root of 2 times the square root of x times the square root of y. Now, this one, there is something wrong right here. So let's go ahead and let's do that problem. It was close, but not quite. So I could rewrite this as 2 times 100 times x squared times y. Why did I break 200 down to 2 times 100? Because 100 is a perfect square. The square root of 100 is 10 outside. The square root of x squared is an x outside. So this is what your answer should be, okay? Now, the answer that the student had was this, and this part of it should have been an x outside, and then they should have combined things like we've done before. Okay, let's see. 32, same thing. 36, same thing. 39, okay. And then I want to take a look at number 39. Here, again, the answer that they had wasn't wrong, it just wasn't complete. And I'm just going to say this, they had L equals 2 square roots of 40 feet, okay? The correct answer was 4 square roots of 10 feet. Now, how do you get from what they had to the correct answer? Well, 40 is 4 times 10. So the square root of 40 is the square root of 4 times 10 is 2 square roots of 10. So this would become 2 times and then 2 square roots of 10, and there's your 4, okay? So again, to that student, you were so close, just needed to keep going a little bit further to combine things. So there you go. All right. Do you have any questions, Russ?
No.
Okay, then let's go ahead and take a look at this new section, which was 9.4. Okay. And let's see here. All right. I want to sort of review some things that if we think about it, we already know, but we're going to apply those. All right. The cube root of 8 cubed is 8, right? And the square root of 5 squared is 5. And the 7th root of 32 to the 7th power is 32. You okay with that?
Mm-hmm.
All right. So what about the square root of 5 squared? So here, the square root of 5 squared is 5, where we're squaring it and then taking the root. But what about the square root of 5 squared? Is that also 5? Yes, it is. In fact, here, let's expand it. That would be the square root of 5 times the square root of 5, right? Which would be the square root of 5 times 5, or the square root of 5 squared, or of 25, which is 5. You okay with that?
Mm-hmm.
So what's the square root of 7 times the square root of 7? It would be 7. What's the square root of 49 times the square root of 49? That would be 49. What's the cube root of 4 times the cube root of 4 times the cube root of 4? Well, that would be 4. Okay, you're good with that?
Yep.
All right, because we're going to take that to the bank. Here we go. It says multiply and simplify. All variables represent positive real numbers. So we don't have to worry. That's as opposed to saying they're unrestricted. This means that the variables are positive. We don't have to worry about absolute value bars. Okay. Now, multiply and simplify. I have the square root of 5 times the square root of 15. I want to look at a couple of different ways of attacking this problem, and then you can decide for yourself which way you prefer, which way you think is better. One thing I could do, I could rewrite this like that. Okay, 15 is 5 times 3. Then I could rewrite it like that. In other words, this becomes this, which becomes that. So far, so good. But this is what? That's 5, and then the square root of 3. In other words, the square root of 5 times the square root of 5 is 5. So I pulled the square root of 5 out of that to put it with this one to make it a 5 outside the radical, and then square root of 3. So you okay with that? Let's look at a different way of doing the same problem. We could say, well, that's the square root of 5 times 15, which is the square root of 75, which is the square root of 25 times 3. But the square root of 25 is 5, and so I can do it that way. Okay. They both work. I think I tend to prefer this way. It just seems like a little less work, but they both work. The point is you're trying to create square roots of squares so that you can kick them out of the radical. Okay, let's take a look at this one. Negative 3 square root of 11 times the square root of 30, square root of 33. So I could rewrite this as that. Okay. Somebody's frantically trying to call me, but they're just going to have to wait. Sorry, it's distracting me because my phone's buzzing over there. Okay, so then this is negative 3 square roots of 11 times the square root of 11 times the square root of 3. Okay, this is 11. So I've got negative 33 square roots of 3. So again, what did I do? I looked at this and I said, oh, 11 is a factor of 33. So let's pull it out of there, put it with the other square root of 11 to get 11. Okay. This one's a little trickier. 2 cube roots of 16 times negative the cube root of 4. There's an implied 1 there. So negative the cube root of 4 is like negative 1 times the cube root of 4. Okay. I'm going to do this kind of the long way, and then I'll go back and shorten it up. But I could think of this as 2 times negative 1 times the cube root of 16 times the cube root of 4. So in other words, I'm putting the non-radical numbers, the numbers that are outside of the radical, putting those together. Okay. So this is going to give me what? Negative 2. But now what about this? Well, 16 is 4 times 4. So what if I rewrote that as 4 squared and then this as 4 inside? Okay. So now what do I have? I have that, right? Putting these together. But isn't that 4 cubed inside 4 squared times 4? So the cube root of 4 cubed is 4. So my final answer, negative 8. You see what I did? Okay, let's streamline the whole process. Just so, in other words, there's nothing wrong with doing all the steps I did, but if you can see what's going on and don't want to bother writing each one of those steps, this would probably be the faster. I'd say negative 2 cube roots of what? 16 times 4, negative 2 cube roots of 4 squared times 4, 4 cubed, negative 2 times 4, negative 8. But again, it's like, what are you looking for? Well, I'd say, oh, that and that, those can all be written as 4s. Okay. You okay with that?
Mm.
All right. Now, I could have broken them down further. I could have taken both of these and broken them down into 2s. But I could see that, oh, that'll give me 2 4s. There's a third 4, 4 cubed, cube root of 4 cubed. So I went with it. How about this one? Cube root of 3 times cube root of 18. 18 is 9 times 2 is 3 squared times 2. So I've got the cube root of 3 times the cube root of 3 squared times the cube root of 2. Okay, so I split those apart so that I could put those together. The cube root of 3 cubed times the cube root of 2, 3 cube roots of 2. I was thinking before class today, students are always asking me, when am I ever going to use this stuff? Unless I'm going to be some rocket scientist, will I ever use this stuff? And I'm going to say this. I would say the chances are that on a job, you may never deal with something specifically like this. So what's the point of this? It's training your brain to look for patterns. Okay. In other words, what's the pattern here? Well, I want to get rid of the inside by using the outside index. So I'm trying to find what? 3's that are cubed or something. And so that idea of analyzing for patterns, that's something that you do every day. You may not even realize that you're doing it, but it's helping to develop a way of thinking in your brain that carries over into your everyday life. So there's my answer to the question, when will we ever use this stuff? In case you were wondering. All right, enough of that, going on. How about this one? 3 times the square root of 8x times 2 times the square root of 2x cubed y. All right. So I could put these together, the 2 and the 3, and have a 6. I could put those together and have the square root of 16x to the 4th y. Are you okay with where I got that? So now I have 6. The square root of 16 is 4. The square root of x to the 4th is x squared, and that, which gives me 24x squared square root of y. So that, again, was kind of streamlining the process. But the index was a 2, so I'm looking to create squares inside so I can unsquare them and kick them out. You ever heard somebody say, I wouldn't want to be a member of a club that would have me as a member? Yeah, this is a club that the idea is to get kicked out of the club. If it's the square root club, well, you want to be a square so you can get kicked out. If it's a cube root club, you want to be a cube so you can get kicked out. All right. Let's see here. Oops. Okay. It says multiply and simplify. All variables represent positive real numbers. So same thing as before. But now we're going to be distributing. So we've got 2 square roots of 7 times the quantity 3 minus the square root of 7. So I'm going to distribute this and that. The first one, 2 square roots of 7 times 3. The second one, minus 2 square roots of 7 times the square root of 7. Okay? So this first expression is 6 square roots of 7, and then minus. The second expression is 2 times 7, right? Square root of 7 times square root of 7. So now I've got 6 square roots of 7 minus 14. And there's my final answer. I can't put those together. Remember a previous assignment where we combined like radicals? I think that was just yesterday. So here, those last 2 terms aren't like radicals, so that's as far as we can go. All right. Any questions on that?
You don't have to, or can you reorder that? Can you? No.
You could write it like this.
Okay.
But yeah, and but because addition's commutative, but there's no special form one way or the other. Okay, how about this one? Negative the square root of 3 times the square root of 7 minus the square root of 15. Okay, so we're going to distribute. That's going to give us negative the square root of 3 times the square root of 7, which is negative the square root of 21. Okay, this is going to give us minus the square root of 3 times negative the square root of 15. Subtracting a negative is like adding a positive. I'm going to take the 15 and write it like that. So that I can put those together. And get that. And that's as far as I can go with that. So again, what's the thinking behind this? Looking for patterns. What do I need to get from point A to point B? What do I need? How can I put that together so that I can pull something out? Really, you ever played a game? You have a bunch of cards, like you have 2 of each number, and you put them face down, and then you it's like the match game. You turn up 2 cards trying to get a match. Okay, this is kind of like that, except we can see what the cards are. But it's like, okay, I need a match with that. How can I pull that out of there? Is that same kind of thinking, looking for the match game? Okay, let's see here. Now let's look at some real fun stuff. The square root of 2 plus 1 times the square root of 2 minus 3. I know it's real fun, but for whom, right? Probably just for me. So now we're going to actually FOIL these together. Again, the directions say all variables represent positive real numbers. There's no variables in this problem, so it doesn't matter. But I'm going to take the square root of 2 times the square root of 2, which is 2. Okay. The square root of 2 times minus 3, so minus 3 times the square root of 2, which is minus 3 square roots of 2. Okay. 1 times the square root of 2, so plus 1 times the square root of 2, which is the square root of 2. Love it when my voice cracks. And then minus 1 times 3, or minus 3. Okay. These are like terms, and those are like terms. 2 minus 3 is negative 1. Minus 3 square roots of 2 plus 1 square root of 2 is minus 2 square roots of 2. So there's my final answer. Any questions there? So again, FOILing, taking each product, simplifying it as much as I can, looking for like terms. Okay, how about this one? The square root of 3m plus the square root of 2n times the square root of 3m minus the square root of 2n. Look closely at what we've got there and think back to chapter 6 when we were factoring the difference of 2 squares. If you had something like a plus b, a minus b, and you FOILed it together, you got a squared minus b squared. You took this and factored it, you got that. Well, there's that conjugate pair, the sum of 2 numbers times the difference of 2 numbers. So some nice things should work out from this. All right. The square root of 3m times the square root of 3m is 3m, okay? Minus the square root of 3m times the square root of 2n, which is minus the square root of 6mn, putting these two together inside the same radical, plus the square root of 2n times the square root of 3m, which is plus the square root of 6mn, minus the square root of 2n times the square root of 2n, which is minus 2n. Combining like terms, the middle terms cancel out, and we're left with 3m minus 2n. So the middle terms canceled out, that whole difference of 2 squares. All righty. Let's see here. Square or cube each quantity and simplify the result. So the square root of 7 squared would be 7, right? This is basically the same stuff that I started this whole section with. The square root of 11 squared is 11. The cube root of 9 cubed would be 9. Careful. 2 times the square root of 5 squared. Well, that would be 2 squared times the square root of 5 squared, or 4 times 5, or 20, right? Because here you're attaching that exponent to both of the factors. Okay, so it's not 2 times 5 or 10, it's 2 squared times the square root of 5 squared, 4 times 5, 20. All right? You sure?
Yep.
Okay, if I'm losing you, let me know. Okay, how about this one? -3 cube roots of 10y cubed, the whole thing cubed. So that's -3 cubed, the cube root of 10y cubed. Okay, so in other words, I've got 2 factors inside. So I'm attaching that exponent outside to each of the 2 factors. Okay. -3, the quantity cubed, is -27. The cube root of 10y cubed, the cube root and the cube get rid of each other. And what do we have left? 10y cubed. So we end up with -270y cubed. Again, a thing to be careful of. This 10 is no longer under the radical, right? So don't leave it there. In other words, once you take a square root, that thing comes outside. The radical disappears. Okay. Now, we've talked about simplifying a radical, and that basically means kicking everything outside the radical that you can. There's another process that's called rationalize the denominator. Okay, rationalize the denominator. The idea there is that if we've got a radical that contains a fraction, if there's a way that we could simplify it so that the denominator of the fraction wasn't inside of the radical, then we'd have something easier to deal with. Just for example, if I have the square root of 3/4, that's the square root of 3 over the square root of 4, which is the square root of 3/2. So this one, by simplifying it, it automatically rationalized the denominator. Maybe we need to recall, what do I mean by rational versus irrational? Okay, a rational number is a number that can be written as a whole number or an integer or a fraction or a repeating decimal or a terminating decimal. So for instance, 2 is rational. An irrational number is a number that cannot be written as a fraction or as a whole number or an integer or a repeating or terminating decimal. Now, 2/3 is 0.6 repeating. Okay, 2/3 is rational. 0.6 is repeating is rational. The square root of 3 is not rational. If I punch in the square root of 3 on my calculator, I get 1.732050808. Now, it looks like it's starting to repeat. But if my calculator went out further, what's really happening there is this, whoops, had the eraser on. This number is being rounded off because the calculator ran out of room. I don't know if you can see that. So if let's just say that I had a calculator that showed 100 decimal places, it would fill up the screen and the last digit would still be rounded off because, well, that's as far as we've got room for. So the square root of 3 is irrational, whereas 2 is rational, okay? So in this case, when we just simplified it, it automatically rationalized the denominator. But let's take a look at another example. Let's say we've got this. The square root of 5/3. So that's the square root of 5 over the square root of 3. This does not have a rational denominator. So the question is this: what can I multiply the denominator by so that I have a rational number in the denominator? Well, the square root of 3 times what would be, let's say, 3. Well, the square root of 3. But if I multiply the denominator by the square root of 3, I've also got to multiply the numerator by the square root of 3. And my new numerator is the square root of 15. Now, is this nicer than this? Well, yes, in that. Now, if we're trying to do something with the radical, we don't have to deal with a fraction inside of it. We're just dealing with the 15 inside. Okay, but this process is called rationalizing the denominator. You okay with this example?
Yep.
All righty. The square root of 8/7. That would be the square root of 8 over the square root of 7. So I'm going to multiply the numerator and the denominator by the square root of 7. Okay. Now, I'm not done. The previous problems, there wasn't anything more I could do, but here I can actually take the 8 and break it down. Okay, 8 is 4 times 2 times 7. The square root of 4 would be a 2 outside, and I've got 14 left inside. Okay. So not only did I rationalize the denominator, but I simplified as well. See what's going on there?
Mm-hmm.
Okay, I know, a lot of stuff. Okay, now let's take this one. 8 over the square root of 10. So this one has the numerator rationalized, but I want the denominator to be rationalized. So I'm going to multiply the bottom and the top, both by the square root of 10. Okay, so far so good. But now I can come back and I can reduce that 8 outside and the 10 that's outside. So I get 4 square roots of 10 over 5. And even though the 10 inside breaks down to this, these 5s are not compatible. I have a little saying, they're not compatible if they're not both inside the radical. Square root of 5 and 5 are not the same flavor of ice cream, okay? So you can't do anything with that. They've got to both be outside or both be inside. If I had something like this.
Wait, so for that last one, that would be like no solution, or? Oh, I gotcha.
Yeah. Now, if I had something like this, then I could come through and cross those out because they're both the square root of 5. But don't confuse the square root of 5 and 5 as being reducible in their present state. Okay.
Mm.
All right. Let's see here. How are we doing for time? Okay. The square root of 15b squared over the square root of 5b cubed. Okay. Now, this is going to be another case of where I'm going to show you a couple of different ways to do it so that you can decide which way you prefer or explore on your own. But just, you know, there's rules. You can't break the rules, but there's ways you can do things differently. So I want to rationalize the denominator. The most obvious first move would be to do this, because that would give me that. Now I'm not done, but that would immediately rationalize the denominator and I could go from there. Okay. Now I said it was the most obvious move. It doesn't necessarily mean it's the best move. We're going to come back and revisit this problem from start to finish again, but I want to keep going with what I did here. So I immediately rationalized the denominator. Okay. But there's some things I can do with the numerator. Let's see. I'm going to take the 15 and the 5, and I'm going to write it as 3 times 5 times 5. And then b to the 5th, I'm going to write as b to the 4th times b. You see what I did? Okay, so now this is going to be a 5 outside. This is going to be a b squared outside, and I'm going to have the cube root of 3b inside. Okay. But now I can come back and reduce the 5s and reduce b squared over b cubed to a b in the denominator. And my final answer is that. Okay.
Mm.
Now, this isn't the wrong way to go, but it might be the long way to go. Let's take a look at this problem again. Only this time, I'm going to do this first. This is, hang on. I got myself in too much of a hurry there. So by putting them together and reducing it, I now have the square root of 3 over the square root of b. Okay. Which is the square root of 3 over the square root of b. I'm going to multiply that by the square root of b over the square root of b, and I have the square root of 3b over b. Now, you could argue that I've got 6 steps in both examples, but this one I made things a lot smaller to start with, so easier to deal with. You see that?
Mm.
Okay. Yeah, they're both correct, just a matter of preference. I would choose the bottom one just because it seems to me like it's easier to deal with. Okay. Let's say I've got this 11 over the square root of 75 s to the 5th power. Okay. So s. And again, the directions say rationalize the denominator. All variables are positive real numbers. Okay. So again, I'm going to look at 2 different ways to do this. One of them, again, perhaps the most obvious, is to multiply the top and the bottom by 75, by the square root of 75s to the 5th power. That gives me 11 times the square root of 75s to the 5th over 75s to the 5th. Okay. Now I'm going to come back and I'm going to simplify this stuff inside. My denominator is still 75s to the 5th. I've got 11, and I'm going to write this as 3 times 25 times s to the 4th times s. Okay, again, trying to match the index with exponents or multiples of the index. Okay. So that's going to stay inside. That's going to bring a 5 out. That's going to bring an s squared out. And that's going to be still inside. So now I've got the square root of what? 3s inside. Okay. Oh, I can reduce the 5 and the 75 to 1 over 15. I can reduce the s squared over s to the 5th as 1 over s cubed. So what have I got now? I've got 11 square roots of 3s over 15s cubed. Okay. You all right with that?
Yep.
A lot going on there, but we got there. Now, let's go back and look at it a different way. Let's see if we can look at it a way that's actually legible. Penmanship is not my forte, but you already knew that. What I'm going to do before I rationalize the denominator, I'm going to simplify the denominator. Oops. So I'm basically doing the same thing I did up here, but I'm doing it up front instead of at the end. Let's see. So this is s to the 4th times s. Okay. So I've got 11 on top. I've got the square root of 25, which is 5, the square root of s to the 4th, which is s squared, and then the square root of 3s. Okay. You okay so far? Now, I still have to rationalize the denominator, but now I can multiply the top and the bottom just by the square root of 3s. I don't need to rationalize the part that is already rational. In other words, this part, it's fine. So now this gives me 11 square roots of 3s over 5s squared times 3s, which is 11 square roots of 3s over 15s cubed. And again, you know, it's still the same amount of steps, so to speak, but instead of making things larger and then pulling them apart, I'm saying, oh, you know, let's kick everything out ahead of time, and then we only have to deal with this. Okay. Again, different strategies. They're both, it's not that one's right, one's wrong. I just wanted to show both those methods so, you know, you can decide for yourself which method you like better. Okay. All right. So for the weekend, section 9.4, Monday, we'll go on to 9.5, which is the last section in this chapter. Tuesday is advising day. So there won't be any class, no Zoom meeting, no office hour by me on Tuesday. Okay. I'll be back Monday. We'll wrap up the chapter. Tuesday, no class. If you need to get advising, get with your advisor, that stuff. Wednesday, we'll come back and we'll review for the chapter 9 test on Thursday. Okay. I will also be back this afternoon at 1:15 for office hour. But if you don't show up there, I'll see you on Monday. Okay. All right. Let me go ahead and stop the recording.